Today we'll continue with the series to show Google Onsite interview problem on Leetcode with the mock assessment for premium users. Okay, let's get started. Okay, so we have 3 questions. Given integer n, return the least number of perfect square numbers that sum to n. Okay, product of integer of x, for example 1 4 9 something. So the first of all, I will create perfect square less or equal than this one. So I have a perfect square array. So y so I equal to 1, yi this one. Then I will perfect square, I will append I plus 1. Okay, and then I just try return the least number of perfect square that sum to it. So I just try, and I have in here the sum here, right? Sum remain here. If it's equal to 0, return this one. Otherwise we'll try it for perfect square in perfect square array. If this is still greater than so we need to find the minimum of dp of this one plus 1. Return answer, return dp and okay. So return the minimum. Yes. Let's time complexity of this will be n of n state. This one will be this one. Yes. So this is the time complexity. And space complexity O n. This one O n of this one. Yes. Okay. The second question. To play a turn based on the game on binary tree, given the root of binary tree and the number of node n in the tree, n is odd, and each node has a distinct value from 1 to n. Initially, the first player names a value x with, and the second player name a value y with. The first player color the node with value x red, and the second player color the node with the y blue. Then the player take turn. Start with the first player in each turn that the player choose node of their color. Red if player 1, blue if player 2, and color uncolor neighbor of chosen node, either the left try, right try, or the parent of the chosen node, if and only if a player cannot choose such node in that way, they must pass their turn. If both players pass their turn, the game ends, and the winner is the player that color more node. You are the second player. If it's possible to wise to ensure that you win the game. Okay, so I have a binary tree here, number of nodes, and for the x here, for example, if x here, x is the X is the red one. For example, if X like this, if X like this, try it. Okay, so if this is the X, then the best way, because it turn to a node of their color and color neighbor of chosen node, neighbor of chosen node. Take turn to a node of their color and to a node of their color and color and color neighbor of chosen node. Left, right, try or the parent. So so the X can only this one. So if I choose this one as the, if I choose this one as a Y, then this one should only eat this one. If I choose this one, then other will belong to X. If I choose this one, and other will belong to X. So I need to if I choose this one, then how much for X and how much for Y. If I choose this one, then I know how much to X for how much to Y. Okay, then I need to store the parent of it, the left try, the right try, and I need to have a def function to calculate the number of nodes in the subtree. Okay, that's the idea. So let's get started. Root if root equal to none, then return 0. So return number of nodes in subtree has root as root. Okay, then I need to store like X parent, X left, X right, parent, X left, X right. Okay, if root equal to root dot value equal to X, I need to store the parent. Then X parent equal to parent. X dot left equal to root dot left, X dot right, root dot right. Yes, and it should be as root dot left, parent is root, plus what is it, root dot right, parent is the root, plus 1. This is the number of nodes. Okay, and leave as root and parent here. Okay, and then I just compare. If for example, if I pick this one at the Y, I have many cases, right? The first one, parent. If I pick this one, okay, one, pick parent of X for second layer. Okay, if I pick this one, then I need to know number of nodes up. A player to win, so I need to maybe I have a if I choose this one, if I count 1 count 2 return count 2 e greater it is a number of odd choice. Okay, if e player to win, the player to should be total not minus with the this one minus with this one, so x not x count not x. Maybe we have a count. Okay. Count of root equal to rest. Okay. Minus total not minus one so should be the count of x not okay, so count of x not. Okay, and this one is total not minus count of x not. And 2. Okay, 2. Pick x left for the second player. So if player to win. So if it is 1, then total not minus count of act of left. About none should be act of left. Maybe count of none will be 0. Okay. This one and this one count of x left return 2. Pick x top right the second player if player to win. Do the same with the right. Back right. 2 false. Do what the hell is that, bro? What the hell is that, bro? X only exit. Yeah, X always exit. Why? Maybe because of this. Yes. Okay. Okay, I'm fine. Okay, campus and assign one back unique pi to each worker, so that's some Manhattan distance between worker and bike is minimized. Return the minimum possible sum of Manhattan distance between each worker and the same bike. So for this one, if this one like 2, this one is 2, so it's a 4. Sorry, this is not 2, this is 3, this is 3, so it's 6. If this one 6, should be 8, total 8. So this one just brute force. So okay, so n is the number of worker, m is the number of bike. Okay, I will dfs to try db. So it's a high worker u bike mask. Okay, we will look through bike in the range of number of bike. If bike is not used, it means this one is already you, then skip. Is it not you, then I have a new mask. Will be this one. What? This one. Yes. Okay, and then I just have a function to calculate Manhattan distance. Manhattan distance v1, v2, return absolute difference v1, v2 plus absolute difference v1, v2, Manhattan distance. Okay, so this will be Manhattan distance of workers, a worker, and bikes, a bike, Manhattan distance. So I need to pick the one with minimum. Pick the one with minimum. So I initialize with maximum, and the mean of ends, and this will plus with next one, and the new mask, the distance here. Yes, and I need to choose the one with the minimum. Cache is okay. Return of dynamic programming from 0 and not used yet. Is it simple like this? If it's enough to the number of worker, then return no distance. Yes. So it's like DVS. Try all this worker. Fine, not correct. What's wrong? What? What wrong with me? What wrong with me? What wrong with me? What wrong with me? What the hell is happening? Minimum possible. If the bike already used, then skip. Otherwise, new mass equal or with this one turn on one. This Manhattan distance up. This one and this one. Answer will be the minimum between way. What wrong with this? What wrong with it? What wrong with this? Okay, let's try it. Worker. Worker. Euro. 1 2 euro. Okay. And bike 1 euro. Bike 1 euro. 1 euro. Okay. 2 2 2 2 2 1. So this is an A3. Distance should be 4, but we put 3. How can 3? How can 3? Back. What the fuck am I doing? What the fuck am I doing? Yes. Does it correct? Okay. So what the time complexity of this? So what the time complexity of this? The time complexity of this will be number of state will be n multiply what u mass. How many mass we have? This one. So this one multiply by this one m, where n is the number of worker. This one is less equal to 10. M here less or equal to 10 is the number of bikes. It's bike complexity will be this one, the number of state. Number of state, yes. Yes. So this one will be 10 multiplied by this one is very cheap. About this one is very cheap. Very cheap. Yes. this one can we optimize this a little bit. So time complexity of this one will be n, because the deep s every node visit only once. By complexity of this will be n, or the depth of the stack depth of the deep s. In worst case will be n. Yes. Yes, I think that's all.